Hello everyone, welcome to our channel Physics for AP, and today we're going to discuss about matter in our surroundings. So we know that matter is anything which occupies space. So anything which occupies space is and mass is said to be called as matter. So anything which occupies a certain amount of space, x-axis, y-axis, z-axis, which occupies a certain volume and also which has a mass for it, so it's said to be called as a matter. And we know that matter is divided in three types, that is solids, liquids and gases. So actually we have 5 states of matter. Along with the solids, liquids and gases, we have plasma state and Bose-Einstein condensed state. So what is this plasma state and what is Bose-Einstein condensed state? So plasma state is the state in which the ions are present. The anions and cations, the positive and negative charges are present. So this plasma state can be seen on the layer of our Earth's surface, that is ionosphere, and also we can see the burning of sun and the stars as they have been burning continuously. So the state which is present there we call it as the plasma state, which has very extreme high temperature. And coming to Bose-Einstein condensed state is the state which the particles won't vibrate at all. That means the state which is being taken to extreme very low temperature, so that the particles will be stopped vibrating it. So that is what we call as the Bose-Einstein condensed state. So we have 5 states of matter. One is solids, liquids, gases, plasma and Bose-Einstein condensed state. So when we come in an order, so we take Bose-Einstein condensed state, and next solid, next liquid, next gases, and the next is the plasma state. So this is the correct order which we need to remember here. But we will discussing about the solids and liquids and gases over here. Now let us learn the properties of and the characteristics of solids, liquids and gases along with the experiments which we are doing. So what are we waiting for? Let us move to our today's topic, matter in our surroundings. Here we have the properties of solids, liquids and gases. So solids have definite shape and volume. Liquids don't have definite shape but they do have a volume. And gases, they don't have a definite shape and they don't have a definite volume. And the compressibility and the space between the particles and how they are being attracted with each other. So solids have strong attraction where liquids and gases will have low. And these are the properties of solids, liquids and gases. Now let us perform an activity based upon the solids, liquid and gases. So here we have a solid substance which is a wood, and the particles which are present inside the solid are being closely packed to each other. So due to the combined package of the particles, so they form a definite shape and size. So they form a definite shape and size, and also they have a definite volume too. And as the particles are being closely arranged, they cannot be compressed. So when you apply force on two sides, so they cannot be compressed. So what we can say is the particles which are present in the solid are being closely packed towards each other, and due to the closely packed of each other, they form a definite shape and size, and also they have a definite volume. And due to the closely packing of the particles, they cannot be compressed. So they cannot be compressed over here. So this is about the solids over here. And next, coming to the liquids, so we can take the best example of liquid for water. So here we have a water which is a liquid state. So the particles which are present in the liquid are somewhat loosely packed when compared to the solids. So due to the loosely packing of the particles, they won't have a definite shape. So they won't have a definite shape and they can flow from one place to another. Like if you pour some water drop, so you can see the particles which can flow from one place to another place. But when you see for the solid, so the solids don't have a particular they don't have the flowing property. So why? Because the particles are closely packed, and in this liquid, as they have been loosely packed, so they can flow from one point to another point, one place to another place. And they don't have a definite shape. But they do have a definite volume. So they take the volume of the container which we are taking, whether it is a glass or a beaker or a flask, anything. So it takes the shape of the container which it has. So the container which we are taking it takes the shape of it. That's it. So due to the reason of the loosely packing of the particles, they flow from one place to another place, and they don't have a definite shape. So this is about the liquid, and we have an activity here about the liquid. So let us see the activity. So we have a glass of beaker of water, and I have a salt. So now what happens when we pour 1 or 2 spoons of salt into the water? Yes, obviously it will dissolve. So let us see. As you can see, we have clear water. Now what happens when we pour a drop of salt into it? So 1 spoon of salt. Now let us stir it. Now observe the water now. Is there any difference before and after? So is there any difference before and after? So somewhat it has been changed its color. So if you see the previous water glass, the previous one and the present one, so this is the salt and this is the normal water. So there is no much more difference, but slightly, that is 0.1 difference, you can observe it. So what happens to the salt particles? As salt is a solid, right? So salt is a solid particles. So when we mix into the water, it dissolves and mix along with the water molecules. We have learned that about as the liquids we have here are been little loosely packed here. Now when the salt particles are been added to the liquid, salt are nothing but solid here. When the salt particles are been added to the liquid, they get dissolved and they mix in between the liquid particles over here. So due to the reason, we cannot see the difference of the water here. So everybody think it's just like a normal water, but it's a salt water. Why? Because the salt which we are mixed, as there is a space in between the liquids, the salt particles has been mixed into the space which are present in the liquids. So by this experiment, we can say that in liquids there is a space in between them. So in liquids there is a space in between them. So how can you prove that with an activity? By salt water. When you add salt into the liquid or water, so it gets dissolves and the salt particles are been mixed with the liquid particles. As there are space in between them, it get mixed in between the liquid particles here. So this is about the liquid characteristics of the liquid. And coming to the gases. So gases, we already know the air which we are taking, the oxygen gas or the air which we are taking is the gas. So how can we perform an activity for a gas? So in the gases, we already know as they are been very loosely packed. So let us see an activity. So we have an incense stick, an agrabati. So you won't get any smell unless you light it. You won't get any smell, right? So when you keep at the corner of the room, you won't get any smell of this incense stick unless you light it. But once you light it, let us see. now we have lightened the agarbatti. As you can see, the gas which is coming out from it, and if you keep at the corner of the room, you can smell it, the perfume of that agarbatti. So why? Because the the particles, that is the fume which are coming, it is a gas. As the gas particles are very loosely packed, so they can escape anywhere, so they can move from one place to another place very easily. And the particles, the gas, they don't, as they are being very loosely packed, they don't have a definite shape, and they don't have a definite volume also, as they are moving from one place to another place very faster when compared to the liquids. And what we can say, so when compared to the solids and liquids, gases can be compressed very easily. So the gases which we have here, it can be compressed. Liquids somewhat we can compress, but solids we cannot compress, as they are being closely packed. Liquids, as they are little bit loosely packed, so we can compress a little. But the gases, as they are being very loosely packed, we can compress them. So we can, by compressing it, we can convert the gas into the liquid. So that is what we call the compressive property. And also we can say that the liquids and the gases both are said to be called as fluids. So why they are said to be called as fluids? Because they can move from one place to another, they can flow. So they can flow from one place to another place, that is from high level to low level. So that is what we can say, that the liquids and the gases are said to be called as the fluids. And so this is an activity about, we can show that the gases, they can move from one place to another place, and the gases particles are very very loosely packed, so they can be compressed easily. And also we can say that the gases can be compressible easily, like we have the compressed natural gas, CNG, the compressed natural gas, and the liquid petroleum gas, what we have, the LPG gases. So all they are being compressed in the form of liquid, and when we lose the compressibility, it converts into gases. So now let us perform another activity to show about the diffusion property. So diffusion is which mix with one to another. So let us perform an activity upon the diffusion now. Now let us perform an activity upon diffusion. So diffusion is nothing but intermixing of the particles from higher concentration to lower concentration. And let us see the diffusion when it gets mixed to each other. So here I have a color powder. Actually in our we need a potassium permanganate crystals over here. So we don't have potassium permanganate crystals, so the experiments which are present in our home, we can do it. So here we have a color powder. So let us see. Now we have observed the color change over here. When I drop the color powder into the glass, you might have seen there is a diffusion, that is all the particles has been spread towards the liquid over here. So this is what we call the diffusion property. And let us see, when we drop the water, the particles over here, when we convert into this, that is a few drops of water of the color powder over here, when we drop into this liquid, let us see what will happen. Can you see the diffusion properly now? See, it's as it is been spreading out towards the whole liquid particle. So this is what we call it as diffusion. So we call it as diffusion. Now again, let us take 2 spoons of this liquid solution into this beaker, into this glass. So let us see what happens now. Can you see the color change over here when compared to this? So you can see the change of the color now. So this is the normal water. This is the beaker which we have taken from here to here and from here to here. As you can see, the color particles which are present in the liquid, somewhat little bit rarely you can see it. So by this experiment you can explain about the property of a diffusion, and also we can explain about that each and everything is made up of particles. So the color particle which we have here, when we convert into the water, there you can see the color particles. Again, when you convert into this, there also you can see the color particles. So the particles are everywhere which are present around us, and here this is an experiment about to show the property of a diffusion, to show the diffusion property. This is an experiment over here. So let us see, observe it once again, the property of diffusion again. So observe it carefully. See the property of the diffusion. So as it mixes everywhere. So this is what we call diffusion. So this is an activity upon the diffusion, and to show the particles are present everywhere. So even the minute particles also gets mixed into each other. And also we have another activity to show the rate of diffusion, which whether it mixes faster or slower, the rate of diffusion that we will be seeing in our next activity, which we are going to perform now. Now here we have 2 beakers of water. So one is of hot water and other one is a cold water. And here I have a question over here. You might have seen your mother cooking the food, the color rice or biryani, and you might have observed that your mother adding the food color at the end of when the rice has been completely boiled up. So your mother won't add the color powder before, that is while washing the rice, they won't add the color powder at the first time, but when the rice has been completely boiled, then only they will use the color powder. So what is the reason behind that? So let us see. Here we have an activity. So this is hot water and this is the cold water. Now I'm taking 2 pinch of color powder and adding both into it. Now let us see in which the diffusion occurs more. That means the rate of diffusion will be present more in hot water or cold water. That you need to answer it now. So let us see it. So I have taken 2 pinches of color powder, the same, and let us observe it once, and in which does it the rate of diffusion is more, whether in hot or cold. On this side we have hot water, on this side we have the cold water. Now let us observe it. Observe it carefully. Okay, clear. Now let us see it. See, in hot water it has been completely diffused here, but in cold water still there is a droplet of water that is not been completely mixed up. But here when you see in hot water, it has been completely mixed throughout there uniformly, but in cold water it is not mixed uniformly, as there you can see it is not mixed at the top of it. So here at the top of it, it is not been mixed up, but in hot water it has been mixed up uniformly here. So the rate of diffusion is more in hot water when compared to the cold water. Now for this cold water you need to stir up to mix it uniformly, you need to stir up. But for hot water you no need to mix it up, it will mix it up uniformly by itself. Why? Because the reason is, so we have a reason here. So the reason is the rate of diffusion is directly proportional to the temperature. That means if the temperature is more, the rate of diffusion is also more. And what about the temperature? If the temperature is more, the average kinetic energy is more. That is, each and every particle present in here has some kind of a kinetic energy. So kinetic energy is not the energy which moves from one place to another place, one point to another point. So if it want to move it from one point to another point, it needs energy. So that energy we call it as a kinetic energy. So in liquids, we are discussing about the diffusion. As the temperature is more, the kinetic energy is more. That is, it has more kinetic energy. When it has more kinetic energy, the particles will not be there at its position. It moves out randomly in all directions as it gains kinetic energy. When we give temperature to the liquids, the particles gain the kinetic energy. That means it gains the heat energy. It has been converted into kinetic energy and it is moving from one place to another place randomly in all directions. So due to this reason, the hot water which we have, the saffron which we have in the hot water has mixed it up randomly by itself. Why? Because the kinetic energy is more present in the hot water. So the particles move randomly with more amount of energy. But when you compare to the cold water, there still you can see the difference between the hot water and cold water. There down you can see it has still the color water has been present, but up somewhat left out. So as the kinetic energy is less in the cold water, so the particles cannot move in all directions over here. So they can move, but they won't move faster when compared to the hot water. So we have a formula for the kinetic energy. So the kinetic energy formula is, we have the formula as half mv square. That is half into the mass into the velocity square. So when the temperature rises up, the velocity also rises up and it moves throughout the liquid here. So that is the main reason the diffusion is more when in hot water when compared to the cold water. So till now what we have discussed is, we have discussed about the solids, liquids and gases. And what we have discussed, in solids the particles are being closely packed to each other, so they cannot be compressed. And in liquids they are little bit loosely packed, they can be compressed a little bit. And gases, as they are being very loosely packed, so they can be compressed easily. And the solids have a definite shape and size. Liquids don't have a definite shape, but they have the volume. They take the volume of the container. And the gases, they also don't have a definite shape and they don't have a definite volume, as they move from one place to another very freely. And solids, they cannot flow from one place to another place. Liquids, they can flow from one place to another place. Gases, they can flow from one place to another place. As liquids and gases can flow from one place to another place, so they are said to be called as fluids. And solids, the particles are being closely packed. That is, the molecular attraction are very more and strong in solids. The molecular attraction are weak in liquids. The molecular attraction are very weak in gases. So molecular attraction is the attraction between one molecule to another molecule. That is, from one particle to another particle. The attraction between them is very less in gases, less in liquids, and there are more attraction present in the solids. And these are the differences between the solids, liquid and gases. And we have discussed about the solid, we have discussed about the solid, we have discussed about the liquid, and we have discussed about the gas. Right now, thank you for your time for watching it. Please subscribe the channel, give your valuable comment, and I'll be waiting for your comment. Thank you one and all.